Hi, this is Mr. Mitchell with another video. Here are the questions. Here's the video. We're going to talk about states of matter. States of matter, you have different forms in which matter can exist, and the most common forms, of course, are solid, liquid, and gas. And you can see what happens with H2O, water, how it's a solid is when it freezes and is ice, how it's a liquid is in its natural state, and it can be evaporated and turned into gas. But those are not going to be the only three, but I do want to kind of expound a little bit on those three. It's still all the same substance. It's a physical change, not a chemical change. Looking in my notes to see if I have anything. Different particles in a solid are usually, particles in a solid are usually closer together than those of a liquid, and particles of a liquid are closer together than those of a gas. There is an exception, however, and the exception is right here. It's water. In water, you actually have more space in ice than you do in water. The particles, the molecules, are actually closer together in water, in liquid form, than they are in ice form. And that's an exception to kind of the general rule. And it's very important for life on Earth. I have a picture of some ice floating down here. Ice would not float if that were not the case, where you had more space between the particles of ice than you do the water. Most everything else, if you have the solid portion, it would sink in the liquid portion. I think your book is going to use the example of steel. If you have liquid steel and put solid steel in the liquid steel, it sinks. And that would be true, I think, for pretty much every other change from liquid to solid. The solid parts would sink. But molecules of water, fortunately for life in the ocean, are far apart. I mean, can you imagine what the world would be like if the ice sank to the bottom? It would be much easier for the rest of the water to freeze, and therefore, since the ice is on top, it kind of acts as a protective barrier. It keeps the bottom, the water at the bottom, from freezing as quickly. So scientists think that this is something that may even be a life or death type determining thing, just because of the fact that molecules are farther apart in the solid, the ice, than they are in the water. It's kind of one of those amazing little things that just happen to work out for our benefit. The particles of some solids actually have patterns, like this crystal here. Solids of ice, salt, snow, can have crystals, little bitty crystals, and you've probably seen it. I think it's at the grocery store when you're in the frozen food section. There have been times when I've looked through the pane of glass and there's like a crystal formation there, and that's what sometimes happens. Liquids here have a definite volume, but not a definite shape. I mean, you're going to have exactly that amount of liquid no matter what container you pour it into. It's just going to take the shape of the container. Liquid molecules are close, but not as tight as a solid in most instances, that is. Now, a gas has no definite volume. If you were to take condensation, evaporation of, I guess I'd better say evaporation, and have this vapor here, you could put it in any size container and its volume actually will change. It's not as measurable a volume of vapor as it was when it was a liquid, as it was when it was solid. It has no definite volume and no definite shape. And even though it says cloud, it looks like a cloud here. I mean, you know that evaporated water is around you at all points. You just don't see it. And that's more of something that makes it easier to understand, perhaps. Just something to look at, I guess, under the heading of gas. The molecules are very far apart in the gas portion, and anything in the gas state. Now there happens to be another state of matter besides solid, liquid, and gas. It is plasma. Plasma is another state of matter. Now we don't get as much plasma on Earth. In fact, the lightning is made of plasma. But other than that, on the surface of the Earth, you're pretty much going to be limited to the solids, liquids, and gases. But when you get out of this Earth's surface or out of the atmosphere of the Earth, then you have, well, the book's going to say that 99% of the universe is considered to be in a plasma state. So what is plasma? Plasma is when gases have particles that have so much energy that they become electrically charged. We'll go back a page. Here you have the gas, the water vapor. It's not moving quickly. The vapor is moving around, of course, but it's not moving so quickly that it creates an electrical charge. In plasma, that's exactly what happens. The sun puts out a huge amount of plasma. It has a huge amount of heat. The molecules are going very, very, very fast, and because they're going very, very, very fast, they become electrically charged. The lightning is electrically charged, as I'm sure you have either knew or could take a guess that it's electrically charged. They emit plasma. 99% of the universe, like I said, is considered to be in a plasma state. Now, engineers have found a few everyday uses for plasma, and down here at the bottom is probably the one that's most commonly thought of, a plasma TV. Now, a plasma TV isn't like a little bitty sun inside your house, but here's what it is. A plasma is used to cause many thousands of little pixels to light up. And in your plasma TV, if you have one, you have thousands of little pixels. And you can think of each of these little pixels as like a fluorescent light, not near the plasma that you would find at the sun type stage, and not near the danger, but you do have those fast moving molecules that will create an electric charge. So the pixels that create a tiny fluorescent light are the basic units of these televisions, these plasma TVs. And the computer in the plasma TV controls which pixels light up and when they light up, and that ends up producing the picture that you see. Don't forget to go back and do the questions if you haven't already. I hope you've learned a little bit about states of matter.